A sleeping monster, one of the largest in the world, rests beneath the surface of Yellowstone National Park. It hasn't erupted in over 70,000 years, since the last time lava flowed through the area, but it still carries the potential for devastating eruptions. What would happen, then, if Yellowstone erupted suddenly tomorrow?
Magnesium, or molten or semi-molten rock, builds up in chambers beneath the Earth's surface and is the primary source of most volcanic eruptions. Magma and gas steadily fill these chambers over time as they ascend from the upper mantle and press on the lower crust. A magma chamber under intense pressure has the ability to violently fracture the nearby rock, causing fissures and cracks to appear in the earth. Volcanic material bursts onto the surface through these fissures, either as lava or as solid pieces known as pyroclasts. This is what an eruption of a volcano looks like.
A sufficiently large and intense eruption could release so much material that the magma chamber topples. It is possible for the chamber's walls to collapse inward, creating a caldera, a sizable depression. This closes off the beneath chamber briefly, resuming the accumulation of gas and magma. Volcanic eruptions can range greatly in size and power, from the smallest smokestacks to the most destructive explosions.
We employ the Volcanic Explosivity Index (VEI), a numerical scale with values between 1 and 8, to quantify these natural occurrences. The volume of ejected volcanic material is represented by each number on this scale, which increases by a factor of 10, like the eruption of Mount Vesuvius, which engulfed the ancient city of Pompeii. A level 5 eruption may expel about 1 cubic kilometer of volcanic material.
10 times as much material may be ejected during level 6 eruptions as during level 7 eruptions. Even though many of these eruptions are catastrophic, they do not meet the criteria to be classified as super eruptions, which are limited to the maximum level on the VEI. Some of the rarest and most catastrophic natural disasters in Earth's history are these enormous catastrophes.
Super eruptions can occur when volcanic material that has built up beneath the surface for millions of years finally erupts, affecting the entire planet and ejecting over 1,000 cubic kilometers of material. The Taupo volcano in New Zealand had its most recent mega eruption about 26,500 years ago. More than 100 cubic kilometers of volcanic material were created by this massive eruption, which also drastically altered the surrounding terrain. On the North Island, the ensuing caldera created Lake Taupo, a huge crater lake.
One of the few active volcanoes capable of super eruptions, along with Taupo, is the Yellowstone supervolcano, also known as the Yellowstone caldera. This is mostly because of the vast subterranean magma system that has been active for the last 1 million years and encompasses the majority of Yellowstone National Park. 3 culminating major eruptions occurred at Yellowstone during this time, with the final one at Lava Creek Tuff creating the caldera that is known today. The eruption of Lava Creek Tuff, approximately 630,000 years ago, has caused some people to question if the Yellowstone caldera could erupt again soon.
What would happen if this supervolcano finally erupted is difficult to predict. A VEI 8 eruption has never been seen in the modern era. Although such a dramatic occurrence wouldn't occur without notice, we could be able to identify warning indicators days, weeks, or even years in advance of a catastrophic eruption at Yellowstone. When the magma chamber underneath it fills and bulges, satellites may detect changes in the Earth. Seismographs would record progressively stronger earthquakes that cause fissures and cracks to open. Certain locations may see steam or hot volcanic gas seeping out of the ground, portending a more catastrophic event.
An unusual amount of volcanic material may be ejected by a sequence of climactic explosions if the pressure beneath the crust increases too much. It is possible for a column of superheated pyroclasts to shoot up from the Earth fast enough to enter the stratosphere. Huge pyroclastic rock fragments would quickly cool in the open air and descend to Earth as explosive volcanic rocks. A cloud of ash and volcanic gas may radiate in the meanwhile, covering a range of 500 km and engulfing the region in darkness.
Depending on the wind direction, some volcanic material may be transported from the eruption location as far as the eastern seaboard or the Pacific coast. Hot ash could fall from the sky and compromise aircraft, interfering with communications across the nation. Layers of volcanic debris have the potential to spread across buildings and roads, just like hazardous snow does, endangering cars, electrical lines, and other infrastructure. As crops deteriorate and animals pass away from respiratory diseases, thousands of acres of farmland could be completely destroyed.
If there was a true caldera forming eruption in Yellowstone, The resulting volcanic material might spread across much of the United States, making areas unsafe or uninhabitable. There could be catastrophic pyroclastic flows that shoot out of the bomb site and speed across the surface. These blazing hot streams of gas and volcanic material have the potential to travel at exceeding 100 km/h. One of the deadliest and most devastating types of volcanic dangers are pyroclastic flows, which have the power to completely destroy towns, farms, and forests.
As they rise above 700 degrees Celsius, volcanic particles will scorch, burn, or flatten almost everything they come into contact with. Some pyroclastic flows can be followed by dense, erratic clouds of ash, and can spread hundreds of kilometers from the location of the eruption. These flows' contents may cool and harden into intricate volcanic rock formations after they wreak devastation on the landscape.
Ash and lava come to mind when we think of volcanic eruptions, yet we frequently overlook the enormous amount of energy that is released with each dramatic explosion. More energy might be released by a massive eruption in Yellowstone than by the most potent nuclear bombs ever developed. These destructive explosions might rank among the loudest noises ever heard, a title formerly held by Krakatoa's 1883 eruption. Every climactic explosion could be audible from the eastern seaboard or Mexico thousands of kilometers away. The explosions can produce pressure waves that travel the speed of sound away from the blast site in addition to deafening noise. These shock waves might be powerful enough to circle the Earth several times, bringing with them extraordinary weather patterns and global variations in air pressure.
The immediate death toll from a calamity this unusual and potent is difficult to estimate. Many estimates from geologists throughout the years have put the number of deaths on the first day of the eruption in the tens or hundreds of thousands. Numerous people could be crushed by falling rubble or killed by pyroclastic flows that move quickly. Others might suffocate as ash clouds engulf neighborhoods and cities. A major eruption at Yellowstone would almost probably result in one of the largest death tolls in the modern era. While the precise effects of this tragedy may differ, this calamity would affect Earth's climate and biosphere in addition to taking numerous lives.
Sulfur dioxide is among the gases that volcanoes dump into the atmosphere after an eruption. Sulfur dioxide and water combine to form an aerosol that reflects sunlight into space. This might cause an abrupt cooling off, lowering temperatures and changing the environment for years to come. Similar cooling episodes have been brought on in the past by climactic eruptions, such as the Indonesian Mount Tambora eruption in 1815. The global climate was so drastically impacted by this level 7 eruption in 1816 that it was dubbed the year without summer.
Even while it was obviously disastrous, Mount Tambora released a lot less volcanic material than a real super eruption, which might cause the Earth to enter a volcanic winter, a protracted period of global cooling. A few years of global cooling might wipe out our ecology completely. Whole food chains might break down, susceptible species could go extinct or become endangered, and mankind itself might suffer as sickness and starvation wreak havoc on our community, leading to a sharp drop in the world's population.
Fortunately, there is very little probability of such a disaster occurring. On a geological scale, soon might mean any time within the next 100,000 years. Yet some volcanologists predict that Yellowstone caldera will erupt soon. As of right now, there are no indications of an imminent major eruption beyond the usual seismic activity in the area. Even if sudden indications were found, they might point to a frequent hydrothermal episode rather than a catastrophic eruption every few hundred years. There are massive hydrothermal explosions in Yellowstone National Park, which is home to one of the largest hydrothermal systems in the world. Though they can create craters and take lives, these abrupt outbursts of boiling water, mud, and rock pieces only endanger the immediate area, not the nation or the entire world.
Undoubtedly, the thought of a catastrophic eruption at Yellowstone is alarming. It could be the biggest volcanic eruption in history and have a worldwide effect on our planet. Super eruptions, whether at Yellowstone or elsewhere, are unlikely to happen during our lives, though minor explosions could have disastrous effects. Yellowstone National Park's sleeping monster is unlikely to awaken anytime soon.